Good evening everyone. Today we are going to discuss a relation between electric field and potential, and we are going to show that electric field is the negative gradient of potential. Let us see how it can be done. E here represents the electric field and V represents the potential. dV by dr means change in potential with respect to the distance. A negative sign here means if the change in potential takes place with respect to the distance, then its negative value represents the electric field at that particular point. So we are going to discuss how this comes out. Let us consider a charged particle Q0 which is moved from point A to point B in the field of charge Q. Now point P and point Q are very close to each other. P is at lower potential and Q at higher potential. If we consider the potential of P as V and the potential of Q as V plus dV, then the formula for potential difference we have already derived earlier is work done by charge. A very small amount of work is done when the Q0 charge is moved from P to Q, and let that work done be given by dW. So we see here that the potential difference between Q and P, V plus dV is the potential at Q and at P it is V. So potential difference, it is the amount of work done by a unit positive charge. For Q0 charge, the work done is dW. For unit positive charge, it is dW upon Q0. So this is what we are getting. Next we will see that potential difference, as we all know, it is the work done to move Q0 charge from P to Q. The formula for work done is force dot displacement. Now look at the charge Q0 here. It is acted upon by a force Q0e in this direction. So in this direction a minus Q0e opposing force is required, and this applied force minus Q0e, when it is exerted on Q0, it moves a distance dl. So the work done will be the value of force minus Q0e dot dl is written here. Now this minus Q0e dot dl is minus Q0e dl cos theta. This is the dot product. So finally the small work done will be given by minus Q0e dr. The reason is cos theta here is dr by dl, which we have earlier considered. So dl cos theta represents dr. So instead of this dl cos theta, we can write dr. So we have a relation for the work done. Now previously we have equation 1, and this is the equation 2 which we have derived here. So we'll put the equation 2 in 1, that is, this was the equation 1 in which in place of dW, that is the small work done, we put the value which we have derived in equation 2, and therefore Q0 cancels out and we have a relation dV. Say V plus dV minus V is dV and minus E dr. So we write here E, that is the electric field, is equal to minus dV by dr. The word gradient means the change of any physical quantity with respect to the distance. This is gradient of potential with the negative sign, so we say negative gradient of potential, and which is equal to the electric field at that point. So I hope this is clear to you. If you have any doubt, you can post the doubts. Thank you.